Bismillahirrahmanirrahim. Dear students, today we will start our new chapter, that is unit number 2, kinematics. As the kinematics is the branch of mechanics, and mechanics is the branch of physics which deals with the study of motion of the objects. So everything in our universe is in a state of motion. Our solar system moves through space in the Milky Way galaxy. Earth revolves around the sun while rotating about its own axis. People, animals, air, and countless other objects move about on Earth's surface. The elementary particles that make up all matter too are constantly in motion. So there are two branches of mechanics, that is kinematics and dynamics. Kinematics we will discuss in unit number 2, while the dynamics will be covered in unit number 3. Kinematics is derived from Greek word for motion, and kinematics is the branch of physics which deals with the study of motion without going into detail of what causes the motion. So for this we have to discuss first rest and motion. So a body is at rest with respect to its surroundings if it does not change to its position with respect to an observer or with respect to the surrounding. While motion, a body is in state of motion with respect to an observer if it changes its position with respect to that observer or with respect to the surroundings. So the difference between rest and motion is in case of rest, the body does not change its position, and in case of motion, the body changes its position with respect to its observer or with respect to its surroundings. So position of the objects, in order to understand motion, we must have to know about position. For example, Earth is usually taken as reference, and we often describe the position of an object as it relates to stationary objects on Earth. For example, a teacher's position could be described in terms of where she is in relation to the nearby teaching board. So we can equally use references that are not stationary but are in motion relative to Earth. For example, to describe the position of a person in an airplane, we use the airplane as a reference, not the Earth. So there are three types of motion, that are translatory, rotatory, and vibratory motion. In translatory motion, the changes in position of a body as a whole and the line or path of the motion could be straight or curved. So for example, the motion of a horse, motion of a ball, moving car, falling bodies, rowing boats, and flying birds, etc. Translatory motion is further divided into following types, that is rectilinear motion, curvilinear motion, and random motion. As the rectilinear name shows, that it is a straight line motion. For example, the motion of free falling bodies is called the rectilinear motion. Curvilinear motion, as its name shows, that the curve path. So it's a circular or curve path motion. For example, motion of cricket ball being hit for 6. As you see on your screen, this ball makes a curve. So this is known as the curvilinear motion. The third one is the random motion. So it is an irregular motion, or you can say that the zigzag motion of the particles. For example, the flight of the butterfly or the motion of a gas molecules, as you see on your screen. The second type of motion is the rotatory motion. So it is defined as the rotation of a body as a whole around a fixed axis, or fixed axis means fixed point. In this type of motion, the particles of the body moves in a circle. For example, in case of a compass, you take a fixed point, and around that fixed point you make a circle. So this fixed point on which you fix your pointed needle of the compass, that fixed point is known as the axis. For example, the motion of a wheel of a cycle, the hands of a clock, and the wings of the turning fan, etc. These are all the examples of rotatory motion. Vibratory motion. Vibratory arises from the vibration. Vibration, also known as the oscillation. Therefore, the vibratory motion is also known as the oscillatory motion. It is defined as the to and fro motion, or we can say that the repeated forward and the backward motion. Another definition is the back and forth motion of a body is called about its mean position is called the vibratory motion or oscillatory motion. Mean position or mean point means the middle point or middle position. For example, the oscillation of a mass attached to an elastic spring, the motion of the swing, vibration of the plucked violin string are the examples of the vibratory motion. You can see the different examples of vibratory motion as on your screen, the vibration of the tuning fork or the vibrating tuning fork. It is as same as you have used the forks in your home. A weight on a spring. When the weight is attached to the spring, then the spring will elongate and then it will compress. So this elongation and compression gives us the oscillatory motion. A boy on a swing. When this boy moves in forward and backward direction, so this is the repetition of its motion. Therefore, this is known as the vibratory motion. These are the strings of a guitar. When you strike it, then what happened? Then it will vibrate about its mean position. So the conclusion is the motion of a body can be translatory, rotatory, vibratory, or any combination of the three at the same time. For example, the motion of a cricket ball can have translatory as well as spin. Spin means rotatory motion. The atoms, molecules of a gas can vibrate, rotate on its axis and at the same time can move freely in its container. Objects can be at rest and in motion at the same time. For example, for same event, two observers can have different observations. For example, a body in train is in motion with respect to an observer on the ground, whereas the same object is at rest with respect to another observer in train moving with the object. Thus, the motion and rest are relative. It means we have to specify the observer while telling about rest or motion of a body. As position needs reference, therefore rest and motion also need specification of observer. For example, when teacher changes her position in class while students are sitting on their chairs. According to students' observation, the teacher is in motion. Interestingly, teacher while moving also observes the student to move as well. Similarly, when Sarah leaves in train and her cousin John sees her off, as the train starts moving, Sarah sees John moving to the right with the same speed as John sees Sarah moving to the left. जैसे बेटे हम गाड़ी में बैठे होते हैं तो अक्सर हम कह रहे होते हैं देखें दरख्त पीछे जा रहा है. बेटा दरख्त पीछे नहीं जा रहा होता. The tree is at rest, but you are moving in the forward direction and keeping the tree at the back. Fine. So this shows that the rest and motion are relative to each other. The next topic, the scalars and vectors, that we will discuss in our next lecture. Till then, Allah Hafiz.